transmitter setup I already built earlier using an ESP board, OLED, battery, and joystick. Before moving to the final version, I just wanted to test everything once more and make sure that all the readings were behaving correctly. Before soldering everything down, I connected it back and tested it with the Omni robot one more time. Now it's time to move from the prototype stage into building the actual hardware. I start preparing the ESP board with headers and gradually bring together the main components onto the perf board before moving into enclosure measurements and the design itself. After taking measurements of the important components, it's time to turn those dimensions into a physical enclosure. The first print gives us a rough idea of how the layout and spacing work in practice. Once printed, I clean up the support material and get the enclosure ready for the next stage of assembly. Now I start trimming and arranging the wiring so that I can add the rotary encoder into the setup. Next, I add another joystick to bring in additional control inputs for the transmitter. As an additional input, I'm now adding the popular MPU6050 IMU sensor to the transmitter. This MPU6050 lets the controller detect orientation and motion. I first tested the same idea in a game controller setup to verify the motion response. Now I'm trying to apply the same concept to the Omni robot, where rotating the transmitter along its yaw axis controls the robot's rotation accordingly. Now I've also connected the MPU6050 into the mix. The first version gave me a rough idea, so I adjusted the dimensions and printed a more refined enclosure. Next, I install the push buttons into their dedicated spots. Now I solder wires to the push button so it can be connected back. And repeat the same. Now I connect both buttons to the ESP by sharing a common ground and wiring each one to its own GPIO pin. Next, I fix the perf board into place inside the enclosure. Now I add the power switch. Then I prepare and connect the LiPo battery directly to the ESP board via the switch by taking advantage of the board's inbuilt charging support through USB. After closing everything up, I verify that all the readings are still coming through correctly. I test the joystick response, switch between receivers using the joystick button, and then check the rotary encoder and its button input as well. Everything looks responsive. With everything working as expected, it's finally time to put the transmitter to the test.